All right, let's do this. Think of this as a live design review. We're going to put on our architect hats and solve a problem that, let's be honest, a lot of us are facing these days. Your app is all over the place, maybe spanning multiple clouds, maybe a data center too. So how in the world do you build one single service mesh to tie it all together? That's what we're drawing up today. So picture this. It's a scenario I see all the time. Your application? It's a smash hit. It's growing like crazy, you've got users everywhere, and all that amazing success means you've officially outgrown a single Kubernetes cluster. Now, it's a fantastic problem to have, right? But it's also the kind of problem that puts your entire platform under a whole lot of strain. And that right there is the heart of the issue we're tackling. One cluster just isn't going to cut it anymore. Maybe you need to expand to get closer to your users for lower latency. Or, hey, maybe you're building out a hybrid cloud setup with some stuff on-prem and some in the cloud. Or maybe it's just about having a rock-solid disaster recovery plan. Whatever your reason is, the bottom line is the same. You're going from one cluster to many. Okay, so how do we actually solve this? Let's treat this like we're all in a room together, sketching this out on a whiteboard. It's time to draw up the blueprint for our solution, piece by piece. First things first, let's map out our starting point. What do we have on the table? Well, we've got two totally separate environments. One is a GKE cluster humming along nicely in the cloud, and the other is our trusty on-premises data center. Right now, think of them as two separate islands in a big ocean. They don't even know the other one exists. Now, for the cool part. This is where the magic really starts to happen. We're going to stretch one single logical service mesh right over the top of both of these locations. The key here, the secret sauce, is creating a single control plane. And just like that, we have one place to manage everything, letting us treat these two physically separate clusters as if they were one big unified platform.
Now, the fancy technical name for this whole concept is mesh federation. And I know that sounds super complicated, right? But the idea behind it is actually pretty simple. We are not merging the clusters or anything crazy like that. We're basically just introducing them, teaching their individual service meshes how to securely talk and share information with each other so they can act like one cohesive team.
So that brings us to the final piece of the puzzle on our drawing. How does the traffic actually get from one cluster to the other? Well, we do that by deploying these specialized east-west gateways in each location. And east-west is just a simple way of saying traffic that moves between our own data centers, not traffic coming in from the public internet. These gateways are the literal bridges that finally physically connect our two islands. Okay, our blueprint looks pretty slick. We're done, right? Well, not so fast. Any architect worth their salt knows that designing for the happy path is the easy part. The real job is planning for when things inevitably, and they will, break. So let's talk about the what-ifs. And this is where this whole setup really starts to pay off. The resilience is just incredible. Let's look at two big scenarios. First, what if our entire on-prem cluster just, poof, goes offline? The mesh control plane is smart enough to see that instantly and boom, it reroutes all traffic to the healthy services still running over in the GKE cluster. No panic. But what if it's just the network link between them that breaks? The mesh handles that beautifully too. Each cluster just keeps on chugging along, serving its local traffic, completely independent. The moment that connection comes back online, they seamlessly sync right back up like nothing ever happened. Look, this is all incredibly powerful stuff, no doubt about it. But let's be real. It also adds a pretty significant layer of complexity. So for the final part of our design review, we absolutely need a go/no-go checklist. Before you even think about pulling the trigger on an architecture like this, you have to be able to confidently answer yes to a few critical questions. And really, it all boils down to four foundational, non-negotiable principles. First up, unified observability. Seriously, if you can't see the health of the entire system from a single pane of glass, you're just flying blind. You'll waste days, not hours, chasing ghosts across cluster boundaries. Second, consistent security. You need one way to define who can talk to what and have that policy enforced everywhere automatically. Third, automated failover. The system must be able to heal itself. You cannot be relying on some poor soul getting a frantic page at 3 a.m. to manually flip a switch. And finally, and this might just be the most important one of all, clear ownership. When things break, who gets the call? You absolutely have to have that defined, or every single outage will devolve into a painful political blame game. And that really brings us to the core takeaway. Adding a multi-cluster mesh isn't something you just do. It is a deliberate trade-off. You are consciously choosing to manage more complexity in exchange for that next level of resilience and scale. It's a powerful pattern, for sure, but it should never, ever be the default. You've got to make sure your own foundation is rock solid first. So, I'll leave you with this final thought. You've done all the work. You've designed the system, you've connected the clusters, you've planned for failure. But when that first cross-cluster request inevitably fails, and trust me, it will, is your observability platform actually ready to show you exactly where and why it broke? That, right there, is the real test. Definitely something to think about for your next design review.